All right, so this will be our video still part of the video series for R Studio and R programming. So for this video, we'll be talking about more of data visualization. So how do we display data sets into graphs of different formats depending on the need and the type of the data that we're actually trying to display. So there are actually several ways to make graphs in R, and one approach is a system called the lattice graphs or the lattice graphics. So the first step for using the lattice is to load the lattice package using the checkbox in the package tab. So if you're going to go back, if you're going to remember the video about our packages, one of the packages which we actually installed is the lattice package. So from the description here, we have your trellis graphics for R. Just make sure that it's already checked so that it's already loaded in our script. So if not, or if you want to make sure that lattice is actually loaded, you can actually make use of the keyword require. So when we make use of the require command, meaning we're actually loading this specific package on our current script. So when we try to run this, you won't be able to notice any changes in terms of global environment or whatsoever, because we just loaded the package. We didn't ask for any input, or we didn't require any output for it to produce. Okay, so in Lattice, we make use of different interfaces. So the most common plots that we can create are the histogram, the box and whiskers plots or the box plots, the scatter plots, or in Lattice we call it as the XY plot, and the QQ math or the quantile plots. So just to give you an overview first, x is the name of the variable that is plotted along the horizontal axis. I think that's common knowledge naman. Y is the name of the variable that is plotted along the vertical y-axis. So it's very common. You have the x and you have the y. And if you need an additional variable, we make use of the z, which is a conditioning variable used to split the plot into multiple subplot called panels. So that's the third dimension. If in case our data contains more than 2 dimensions, we make use of z. We may also be encountering the grouping variable, which is used to display different groups differently. So like for instance, we have different colors or symbols within the same panel. So later on, you will appreciate more of those values that are included in our data visualization. Okay, let's start with the first one, which is the histogram. So for this one, we're going to make use of the health evaluation and linkage to primary care dataset. Okay, and that's currently available as part of the R dataset already. So it's already available here in the existing datasets that we have. So if you want to know about that health evaluation and linkage to primary care study, you can make use of the help command. So we have this one. This is the data set for that I was talking about, the health evaluation and linkage to primary care. So the data set are more of the health data and how do we link those data into primary care. So let's try to know more about this data set. So we have here the health panel. So there, health evaluation and linkage to primary care. The HELP study was a clinical trial for adults in patients recruited from a detoxification unit. Patients with no primary care physician were randomized to receive a multidisciplinary assessment and a brief motivational intervention or usual care, with the goal of linking them to primary medical care. So, as we use this dataset, you'll be able to notice more of the medical and health care related terminologies. All right, so let's make use of that. So, since we will be using a histogram, histograms displays a distribution using the important idea that the area of that specific histogram refers to the relative frequency of your data. So where there is more area, there is more data. So for a histogram, rectangles are used to indicate how much data are in each of several bins. So the result is a um, picture that will be shown here in our plots, which is a rough shape of the distribution of your data. Okay, so how are we going to do that? Let's proceed with the coding. So you make use of the keyword histogram. And then we have age. Age is actually one of the fields in histogram, and your data will come from the help list dataset. Okay, and we're going to use 20 distributions. So what is 20 here? So n equals 20 here gives approximately 20 bars for histogram. Right? So let's try to run this. And on our plot here, it shows us a histogram. So yung 20 dito is actually the estimated number of bars that we have here. Okay, so this now gives us the distribution of the age of those patients on our help miss dataset. Okay, so ibig sabihin, if you're going to look at this graph, so someone between 30 or 30, around 30 years old na patient ang may pinakamarami out of the dataset that we have. Okay? So this is the very basic. If you want to make use of other fields, you can just change here yung age na dataset. Okay? So let's modify this code. Sabi natin kanina we have the X and the Y. And histogram represents the frequency. So the area, the bigger the bar is, the more data that we have on that specific range, or the higher the frequency. Okay, so when I was talking about the elements of histogram a while ago, just the X, the Y, the Z, I also mentioned about the grouping variable. So what if we want to group this age here into their gender? Okay, so since our help miss dataset also include the gender, so I can make use of histogram. I can make use of that gender field in order for me to group the variables that I have. So age, then I make use of sex, which is the grouping variable. Data is, of course, will come from my existing data set. And still, my estimated number of bars for my histogram will be 20. So let's try to run this code and let's see. There. So as you can see in our plot panel, I have here two different graphs. So I separated the entire data set that I have. My histogram is presented by age pa rin, pero I separated based on their sexual orientation. Right? The female and the male, as far as the data set is concerned. Okay. So in the Lattice lingo, the two subplots are called panels, and the labels at the top are called strips. Okay, so these are panels, and these are strips. So strips can be placed on the left side if you prefer. You can do this modification later. And you can even condition on two things at once. So if you want to further separate this one into a smaller subgraph, like kunwari, you don't want to separate it just by male and female. You want to separate it by the substance of the drug that they actually used, since that is also available in our help miss dataset. So we can just create a new code, histogram, and then still our area or frequency or density of data will come from age. Then you have here, since we're going to include not just the sex but also the substance, so we have substance plus sex, then data, still with help miss, and still the number of bars estimated is 20. So I'm going to run this. Oh, sorry, histogram. Should be histogram. There. So this is what I was talking about. Like, what if I want to run, or I want to further separate it not just by gender, but also by the substance in my data set. So I used still the age for the frequency or the density of my data. Then I have here the substance plus x. So if you want to group it, you make use of this symbol, meaning this data as my frequency, and I'm grouping it based on sex. And for this time, I'm grouping it based on substance and based on sex. So that will divide the subplot, the histogram, into different subplots based on the condition that you actually specified. Okay. So that's it for for the histogram. Next, we're trying to use, instead of histogram, let's try naman the density plot. So density plots are smoother versions of histogram. So they are primarily like histograms then, kasi they also show the shape of the data that you have, pero they have smoother versions because instead of using graphs, they're actually making use of the points and the line chart to show the thread. Okay? So they are pretty much the same syntax. Instead, but instead of using the word histogram, since we're really using density plot, then that should be density plot. All right, then almost the same set of parameters since we will be dealing with the same type of data, right? So I just copied paste whatever parameters I have on the histogram, but instead of using histogram, I'm going to make use of density plot. So let's try to run this one. There. So still looking at the density, but it's more of the shape of data because it's smoother. So I have here just the dots of the volume. So it depends on what you actually want to show your audience. It depends on what specific meaningful message that you want to relay on your audience in selecting the graph that you will be using to represent your data. Okay. And then let's try the next type. So we're done with histogram, we're done with density plots. The next type is the box plot. So box plot is very famous, especially when you want to see the distribution of data on the perspective of the measures of central tendency. So box plot are made pretty much the same way as histograms, meaning you will be using the same parameters. All right, but this time you don't make use of number of boxes, the estimated number of boxes for histograms, because box plots are actually already designed to include I mean, it will not be showing any bars naman with your data, ex- except of course for the actual box on the box and whiskers plot. Okay, so the keyword for box and whiskers plot is BW plot. Again, take note that R is case sensitive, huh? So we'll be using the same data set. So that will be age and just data is help miss there. Okay, so no need to include this one because we won't be displaying any bars apart from the box and whiskers plot. So if I'm going to run this, oh, it should be BW plot, sorry. There. If you remember on your measures of central tendency, you have your minimum, maximum, your first quartile, your mean and median, then your second quartile. Then you have dots here which represents the outliers, meaning they are not actually part of the central tendencies. Okay, and you can also use conditionings just like how we did it on the histogram. Okay, so let's try to create another line with conditioning. So that will be B plot. All right, and then age. And then the conditioning, we separate, we just make use of that command. So for instance, substance, we separate it by substance lang. And then your data will of course your help miss data set. All right, let's try to run this one. There. See? So we separated it based on the substance, so we were able to create different box plots. You can actually export this images here as image or even as PDF, or you can just copy that one and paste to Microsoft Word, Google Docs, or whatever whenever you want to present this data on your research or on your paper. Okay, but actually there are better ways to do this. What if I don't really want to separate them in different subplots, but I want to include all of them in a common plot, kasi that is how we are supposed to be showing naman talaga the box plots. We want to compare each values or each ranges if we can separate them on a single view or a single plot. So in order for us to do that, let's try BW plot, then age, sorry, should be age, then substance, data, help, miss. All right, so here's a different approach. We don't make use of the grouping because we don't want to group them, but we want to include them in a single plot. Okay, so let's try to run this. Oh, sorry. I shouldn't have highlighted that one. There. So it's a better way of viewing the data that we have because we can be able to easily compare this. Like if alcohol there have more compared to cocaine and heroin, which are fewer or lesser in terms of the density of the data. And that is a pretty much more accurate. Okay, or if you think that the age should be on the, since it's numeric, it should be on the x-axis, then you can just interchange the display. I'm just going to copy paste this one. For instance, you want to make use of substance in your y-axis and use age in your x-axis. So we are expecting that it should be the same, but we're going to tilt this graph on a different perspective. There. So this time, the age becomes the x-axis and your substance becomes the y-axis. And you can further combine that one. Like for instance, you're already okay with that, but you want to separate it. Well, that's pretty much is in R because you just have to memorize or you just have to understand the syntax that we have here. So I'm going to plot the box plot using substance and age, substance as the y-axis and age as the x-axis, and I want to group them by their sex. So I'm going to run. There. So we already have here two different box plots or subplots with their box plots inside, and they're actually separated by their strips for male and female. All right, so let's proceed for the next type of graph. So we're done with histogram and density plot and box plot, and we also have the scatter plot, or we call it XY plot. So scatter plot, from the name implies, so scatter plots are actually made with the XY plot command, and the formula interface is very natural for this. You just have to remember that the Y variable comes first, and its label is also farther left in the plot, if that helps you remember. So let's try to make use this time of the iris dataset. I was able to mention already about this iris dataset on the first few videos that we had. So we have XY plot. Let's try to make use of the iris dataset. So I'm going to put here sepal.length, which is part of the field of the iris dataset. And I'm going to draw the relationship between sepal.length and sepal.width for my data, which is iris. Okay, so let's try to run this. sepal dot width should be capital letter, sorry. Okay, sensitive nga pala. Run. There. So we were able to see a scatter plot. So we have here the length and we have here the width. So if you're going to interpret this graph, meaning majority of the length and width of those data that we have on the iris dataset are on this part. Okay, so it's more of looking at the density of the data and the possible relationship between the two variables that we're actually dealing with. And just like on the previous few plots, we can also separate it using our grouping variable. So sepal.length, sepal.width, I want to group it by their species. So we have your species. Let's try to run. There. So as you remember, we have three main species: the virginica, the setosa, and the versicolor. So even better, for this example, we can actually use the group's argument to indicate the different species using different symbols of the panel. Okay, so how are we going to do that? So we're going to make use of the same code. Sepal length, sepal width, and then instead of using the species, we're going to use the keyword groups. Oops. So groups equals species, comma, data will come from iris. So let's try to run this. There. So the difference between this one is that it separates your data into different subplots, separated by species. For this one naman, they are still contained on a common sub or a common plot or graph that we have, pero the separation comes in terms of color. Okay, so we have the pink, green, and blue color depending on the species that those data actually belongs. Okay, so those are the four visualizations that we actually covered: the histogram, the density plot, the box and whiskers plot, and the scatter plot or the XY plot. So I've already mentioned how you save your photo. You can actually save it as an image or save as PDF, or you can just even copy it from the clipboard. And you can already use that one in your research or presenting your data. Okay? So that's it for the data visualization. I'll see you on the next video.